All right, let's get back to the talks. Next up, we have Mike Lynn. I actually didn't know your name because I just knew your Twitter handle and your Slack admin alias or handle. Mike works at Facebook. They do a lot of really cool Mac stuff, a lot of open source stuff. He's also kind of I would say a guru when it comes to pyobjc. He's very active on the Mac admin Slack channel, which is really helpful, always answering all sorts of esoteric questions. So many times he's given me answers. So today he's going to be talking about some really interesting stuff. So let's have a round of applause for Mike. Woo! Chris, standing ovation.
Oh, thank you.
No pressure. All right, Mike, take it away.
All right. Yeah, thank you for that introduction on there. I think the first time Patrick and I actually were interacting was on Twitter, and me and maybe a couple other people were trying to lure him into joining the Mac admin Slack because he was going over this really great security stuff that we were all really super interested in, and he was going down these paths that some of us had already investigated before, and we were like, yeah, we got some people you can chat with over here that probably talk about some of that stuff. It's been really cool knowing Patrick, and thank you a lot to Digita and Objective-C for putting this on. This is amazing. Mahalo. Thank you for the introduction. My name's Mike Lynn. I am a client platform engineer at Facebook, and I realized that the color I chose doesn't show real well for my name on that first slide. That's okay. I've got lots of names. I work at Facebook. I'm not in corp security, although we got reorged. We work hand in hand with them. I'm on the engineering side for corporate devices. So my job is knowing Mac OS in depth. And here, I'm going to talk to some of that today. As mentioned before, I go by a lot of different names. On Twitter, I'm Mikey. Frogger on the Mac admins and OS Query Slack. And then on GitHub, you can find me under Pudquick, of all things. The repos that you'll find on GitHub are not super stellar. They are old. But if you look at my gists, there are several hundred of them, and they have many pyobjc examples, as mentioned earlier. It's a bit of a treasure trove in there. Just want to give a shout out at this point to the macadmins.org Slack. It's free for anybody to join. There's actually several dozen people that came to the conference here that are members of the Slack already. Even if you aren't a Mac admin, if you are interested in Mac security or IDS or just anything verging on Mac, it's a great community to come hang out in. A lot of people representing lots of different companies there, and lots of different in-depth knowledge that you could tap into. We're very friendly. We don't bite. I recommend you come and join. So today at this security conference, we've talked a lot about Apple and their software and their operating system. My talk here is going to be focusing more on some of the hardware changes that have been happening as of late. So if you're not familiar with your Mac history, the Apple started out on the Motorola processors for the Mac line, good old 68K Macs and all that fun jazz, Mac Plus, back in the day. They are not a stranger to change when it comes to hardware. They also later on went to PowerPC as the replacement for the Motorola line on there. They spent some time taking a stab at Intel processor chips during this, and then they ended up actually eating a little bit of crow and actually giving some credit back to Intel when they switched finally from PowerPC to Intel. So the Mac processor line hardware line has been through, over time, over the decades, multiple systematic underlying drastic changes, whereas in comparison to, say, the consumer PC market, basically Windows hardware, it's pretty much been the same family of x86 instructions with extension after extension after extension after extension for the longest time. Apple definitely plays a different game. They're a little faster, looser when it comes to being willing to make deep underlying changes to the hardware structure of their devices. So what has the mothership been doing as of late? Well, on the not Mac side of things, they've been making some pretty spiffy ARM processors as of late. I don't know if you've been checking out the Geekbench scores for the latest iPad Pros or anything like that, but that chart that I've got there is comparing single-core and multi-core performance of the iPad Pro against a 2018 MacBook Pro. Those numbers look pretty stinking awesome. So some of us have been theorizing that Apple would be at some point here changing from their Intel processors once again to now an in-house ARM processor. Now, that hasn't quite happened yet, but in the meantime, what Apple has been doing since 2017 is they have started rolling out sort of this sleeper device. The 2017 iMac Pro came out to a lot of fanfare for video editing. In fact, they gave, unusually for that model, they gave preview access to a whole bunch of video editing people who raved and reviewed when the iMac Pro was revealed that, oh, I can edit this 4K video and it's fantastic. And in the meantime, on the Mac admin community side of things, we knew that the iMac Pro was the first Apple device that was a secure boot Mac. And we were like, why don't we get this advanced access to these devices? Because these iMac Pros, we understood, were completely, like on the outside, they looked very much like a consumer Mac, but we knew inside, fundamentally, there had been some major changes. And the iMac Pro is not the only device that Apple has done that with. They've since gone on to do the MacBook Pro, 2018 MacBook Pro devices, and then just recently in the October event, they actually announced the MacBook Air has finally been refreshed, and it is now a T2 secure boot device as well, as is the Mac Mini of all things. That means that out of the entire Apple Mac lineup, within the scope of about, it's less than a year at this point. I think the iMac Pro came out in December of 2017. In less than a year, the only remaining Macs that are not secure boot devices at this point are the up-and-coming Mac Pro, whenever that's going to come out. It's very obviously going to be a secure boot device. The iMac, which honestly is very long overdue for just any sort of refresh at this point. I mean, it was a drop in they've already done the iMac Pro. Doing the non-Pro iMac is probably going to be pretty easy for them. And then the MacBook 12-inch, I don't know what's going to happen with that particular device. It's probably just going to honestly go away. But that's it. That's all that remains. Every other device now at this point going forward is a secure boot device. So when I'm talking about aliens among us with these devices, I'm not talking like ancient aliens or something like that. I'm talking here that these are devices that have gotten out into the world that, honestly, for what Apple did to them, there is not enough discussion and understanding about the changes because they did such a good job of it. The secure boot devices, in terms of aliens, is like the Doctor. On the outside, looks like you and me. Everything about these devices is, it just works. It's a Mac like any other Mac. But under the hood, instead of just the one Intel heart here, it's got two hearts going on. It's got the Intel chip and the T2 chip. And in fact, actually, when I was trying to do this analogy, I realized I was stretching it pretty far. It's actually probably closer to this guy out of Men in Black than anything else, because instead of it being just a side-by-side processor like it was in the T1 touch bars, the original, the first time the touch bar came out, there was a T1 chip in there. That's peanuts compared to what they've done here. So in the secure boot devices, here's the diagram, essentially, very simplified diagram of a previous generation non-secure boot Mac. In this particular situation, you have storage, camera, mic, audio, that kind of stuff basically routes effectively straight into the CPU. On the T2, that avenue is broken, and instead those devices route through the T2 which then has PCIe connections to the CPU of your device. It is literally man-in-the-middling the access of some very core hardware functionality of your devices, and it's the puppet master behind the strings. It actually has control over what your Mac can and cannot do in a way that is not possible if they were just side-by-side processors. When I'm saying control, you got to realize that storage block that I've got on there, that's where Mac OS is. The T2 sits between the Intel processor in your Mac and Mac OS. If the T2 says you don't get Mac OS, then you don't boot Mac OS. So when that iMac Pro came out in December, Apple, that was a really planned, targeted release for the first secure boot device, because this was brand new for them. The iMac Pro was basically like a specialty device. I think it's like $5,000 in a stock configuration or something like that. The volume that they expected to sell on it was probably pretty low, so good target for the release of a totally revamped hardware design like this, because if there were issues and that kind of stuff, they didn't do it to their MacBook Pros, which is basically the bread and butter of every corporate, government, whatever fleet out there. Actually, those are probably like MacBook Airs or something like that. But like they chose well on the model that they released this on. The side effect of that price, though, was that it was so restricted in terms of who got their hands on this stuff, that when you're talking about administrators and stuff like that who had to go, oh, there's a sample of this stuff in the wild, I need to get one. God, trying to get like approval to your boss, like, hey, yeah, I know that we deploy, $700 Mac Minis or whatever, but I need to go get this $5,000 iMac Pro because I need to understand what Apple has done to the devices that were ready when they do this to the Mac Mini. Yeah, that's not going to fly. So we're all kind of just like, just screaming it, just trying to get this stuff, like, I need access to these machines. And then when we got access, it was kind of like this still, like, oh my God, what has Apple done to these things? They don't work anyway like we expected. I mean, it was more like this. We were just really confused because a few of us got access to these first secure boot iMac Pros, and the very first thing we noticed was these things don't netboot. That was a shock. Because you had the concept of zero-touch deployment in macOS. Apple has been repeatedly saying over and over, MDM is the way forward, for DEP is the way for doing zero-touch Mac deployment. You just open the Mac and it sets itself up and it enrolls itself. That's cute, but in the real world, we actually need to get these devices out in a timely fashion. And so the way that this is actually done was that people would hold the letter N key on their keyboard, and it would network boot to a local imaging server, which would then do all the automation, put the OS onto the device, all that kind of stuff. And we get our hands on one of these things, and they don't netboot at all. And they're like, okay, so what do we do now? And Tim Perfit of Two Canoes, wonderful gentleman, he actually went out and expensed himself iMac Pro, and just to check out all the things that we actually wanted Apple to do from a preview standpoint for us, the admin community for these secure boot devices. He blogged about the whole thing, like this doesn't work, this doesn't work. He went and he took screenshots of all the kind of stuff that people were running into trying to set up these devices. Because at that time, there was no documentation on it. We knew that these were different devices, but there wasn't a KB article out that showed you how they were different or talked about why they were different or any of that kind of stuff. And so Tim did the community a solid, went and grabbed one of these devices, blogged up everything he could find. And so we're like, cool. So doing network boot imaging for these devices doesn't work. So what does work on these devices? How about target disk mode restore? Like Thunderbolt, hold down the letter TD key and put it into target disk mode, attach it to the machine. We started getting really weird dialogues that were popping up the first time we were booting up these devices, stuff that we'd never seen before, and there was no information about what was going on at the underlying core of all this stuff. They felt very alien. The devices out of the box, they don't actually allow you to boot external media either. So you couldn't go, okay, cool, we can't do netboot, we'll just attach a USB thumb drive to these things and image them with a tool running out. That doesn't work either. Literally, the only thing they would actually boot is they would boot out of whatever was inside them, and what was inside them was stock Mac OS, and that wasn't really useful for us. So yeah, looking at the booting aspect of this, at some point when these devices came out, we realized that target disk mode restore of these devices, an iMac Pro could restore another iMac Pro, but everything else could not restore to an iMac Pro. So there was something special about these devices, or the operating system that was running on it. It came out with a different fork. So I ended up actually doing some investigation about what was going on under the hood that was making the boot process actually work for laying down a OS that I wanted on the device rather than what came out of the box. And in doing that investigation, I found that the secure boot devices picked up some tricks from the iOS world of things. Secure boot devices do personalization. They reach out to an online Apple service where it says, here's the EFI boot binaries that I have, here's my immutable kernel cache, here are the pieces that I need to boot this version of Mac OS. Hey, Apple, can I get a signature back that says I'm allowed to boot this, please? And it's literally the exact same URL that iOS devices reach out to for personalization. If you're familiar with SSH blobs and stuff like that, it's literally the exact same endpoint. So the authorization service that Apple runs historically for iOS devices to say, yes, you're allowed to install and boot this iOS operating system on this device. Now these secure boot Macs had picked up the exact same trick, which makes sense. It's a great security model. I wrote about this to the best of the knowledge that I had at the time. And when I wrote it, I talked about these IM4M manifest files. So the signature happens, they get placed on disk, so obviously something on the machine is checking the signatures. And at the time, my assumption was, well, it's the T2 chip. The T2 chip just looks at the signatures on the thing, and it goes, yep, looks good, cool, we're gonna boot it. Fortunately, recently, Apple has actually published an excellent white paper on this with a lot of good details, including this really cool slide. This is the actual boot chain of the secure boot devices, and a lot of people don't realize that this is actually what's going on under the hood. There was a talk that was given at Mac Sysadmin just this recent year about the history of the boot process, the post, power on, self-test, all that kind of stuff on devices, and he went all the way up to current generation Macs almost, and he had like a little teeny box where it was like, oh yeah, and secure boot happens here. Well, as it turns out, in this chart on here, there's an entirely other device that's booting up. Like it's basically you take that box and expand it, and there's a whole other giant diagram box inside that box. So what's actually going on here is, on every time you turn on a secure boot device, the T2 powers on, it checks its own signature. It is running BridgeOS, which is basically in the same family of stuff as iOS, except specifically for the purposes of being used in these Macs. But it has iBoot and all the things that you would expect to see on iOS. So it has the same secure boot model that you would see in an iPhone. And then the cool part happens right here. The T2 chip holds within itself the firmware for all the models of the devices that are out there. And then there is no SPI flash anymore in the Mac. There is no hardware copy of the firmware of your device. Instead, it is ESPI. ESPI is an Intel protocol that there's a white paper standard for it, where over the wire, a copy of firmware is handed to the Intel chip. It is never written to flash. It is never written to permanent storage on the device. There's no persistent storage of flash firmware modules on any secure boot device. That ESPI hands the firmware over to the Intel side of things, and then it boots up, and it's the firmware that was handed over that's actually doing the validation. The T2 really doesn't even have access to the file system of your Mac at all. It's that little teeny ESPI window that it talks through. It's the only access that it has, and it says, I validated that this is good. Here, you go on and do the next step. And then the firmware itself boots up, and it does the checking of those signature files and all that kind of stuff. Anyone who was eagle-eyed enough that noticed I had two little arrows in there before, that's the little ESPI guy that's hanging out over there. So that ESPI is the one that actually hands the firmware over to the Intel side, and then from then it looks like a traditional Mac EFI boot model. The EFI starts up, looks at these IM4M files, and goes, yep, signature's good, cool, we can actually boot. This actually goes back to part of the Apple KB article that they finally published, which talks about the secure boot utility, where it has multiple levels of security. And I actually go over some of that in my blog post, where the IM4M files, by default, on any Mac out of the box, that signature file is not only a personalization saying that this Mac can boot this operating system, but it's actually a personalization file saying this specific Mac can boot this operating system. It is keyed to the ECID, the unique identifier that's in these T2 chips by default. So you couldn't take these personalization files and then like ship them to another device. They're customized specifically for this Mac. So what's the effect of this from a security standpoint for these new devices? Where everybody remembers probably the Vault 7 leak stuff when that was coming out, and oh my God, through so many like, whoa, panic in the Mac security world type of stuff, because you're talking about the CIA literally having kits for building injectable firmware modules into basically the huge array of like Apple Mac devices and stuff like that. ESPI protocol makes all that go away. Because there's no persistent flash storage anymore, you cannot do a persistent firmware attack on these devices. The firmware is a file inside the T2. When you turn it on, it says, here's the file, and it hands it over to the Intel machine, side of the machine, and then that boots. But when you reboot, that process happens all over again. There is no persistent firmware concept in these new devices at all. That also means that Trammell Hudson's write-up on Thunderstrike attacks and how trivial it was to attach SPI flashers to any Mac, take out your pentalobe screwdrivers, whatever, pop out the back of your MacBook Pro, attach a couple clips, and boom, in 30 seconds, you've flashed persistent malware onto these Macs. These entire classes of attack are dead in every secure boot device that's out there, some of which you might have in front of you right now. So we're talking no netboot, no flash storage for firmware anymore, need to Apple's personalization. So they're different, but you could turn this stuff off, right? So you could just go into the security dialog and you can turn this stuff off. It's got configuration, you can turn off. So it can't be that hard from an administrator standpoint to deal with this stuff if you needed to, boot a thumb drive to image the Mac or something like that. Just turn it off. As it turns out, if you attempt to use the lower part, the allow booting from external media, or change it to no security or anything like that, before you can actually get to this screen, you're going to get an authentication challenge. So Apple agreed that, turning this off probably wouldn't be great. Like if I could grab your laptop out of the airport and I could just boot into recovery and go turn off secure boot, cool, I can put stuff on your Mac and you're not secure anymore. Well, so what they did here was they actually gated access to the configuration behind secure token accounts on your Mac. So Apple has actually married secure boot together with APFS at the hip. When you take a Mac that is secure boot out of the box, you can't actually turn any of these security settings off or change them. You literally have to go through the OS setup process at least once to make an admin account before you can then reboot back into recovery and go through these configuration settings. And then you can turn it off, and then you can re-image the Mac again if you really want to try and go through that crazy rigmarole of all that stuff. But Apple has thought about, this aspect of it, and they've created an extra layer of security on top of the secure boot itself that the APFS crypto users are the gateway to being able to change this. And so you're talking about an operating system that doesn't want you to boot unknown media. Changing it to boot unknown media requires a special type of security account to do the configuration change. Cool. Okay, so let's say I do that. Let's say I go through Setup Assistant and actually set all that stuff up. Is there anything else that happens in there? Well, so as it turns out, there's another file that's dropped on disk on these secure boot devices called bridgeversion.bin. Bridgeversion.bin actually hexadecimally encodes the minimum version of the operating system on your T2, the Bridge OS, that is required to successfully boot this particular Mac OS version. And so in here, it's the little endian Intel, it's a integer for 16, there's 2 of those in a row, and then 1064, and my machine was running 1065, so it's running at least a newer version of Bridge OS. So cool, we can successfully boot Mac OS. If you actually attempt to modify this particular file, yeah, you can bypass like the Bridge OS security and maybe boot an older version of it, Bridge OS that has it, but then later on in Mac OS itself, it still does these additional checks and says, hold on. I know you're trying to do like boot this really old Mac OS that's not trustable anymore or something like that, but Bridge OS still needs to be updated. So now you've got security from a what are we booting standpoint, security from who can make the changes on what we're booting standpoint, and security on the minimum level of operating system for the T2 itself. And when we look back at this diagram on here about the personalization piece of it, the T2 actually does personalization just because, like I said, it's like iOS, right? Like, so when it installs one of these new minimum versions of Bridge OS, it also has to use that personalization service to get that installed. So if you're the type of environment that is like a really locked down government environment that says we got to firewall all that 17 subnet, you know, the Apple 17.0.0.0, which totally ignores all the Akamai stuff and all that kind of stuff. But like if you're in that environment where you say, no, our devices won't talk to APNS, won't talk to any of that kind of stuff, I feel sorry for you, because the secure boot devices are not going to be your friend. Even if you went through and turned off the security, every single security feature, jumped through all those hoops on turning that stuff off, the first time you boot a new version of Mac OS on those devices that actually requires a higher version of Bridge OS than you have on your T2 chips, they have to talk to Apple. You literally cannot turn that piece of it off, even if you turn all the other settings off. So, like, there is some really baked-in stuff on here, and I'm sure a lot of you right now are probably feeling like, cool, I'm super glad I'm not on the admin side of things and I don't have to deal with any of this stuff. But even if you're on the security side of things, I had some presents for you. So we were talking before about external boot media, right? So like from a forensic standpoint, you've got probably 12.5 different Linux variations of like, hey, I can boot this external media for these devices and I can capture a never modified version of the file system off of these devices. Well, first off, you've got to go back through that part on there for actually enabling the booting from external media in the first place, and you also have to turn off the secure boot security for the OS itself, because secure boot, while it works with Mac OS and Windows, it does not actually allow you to boot Linux at this point, so you'll have to turn that off. And then to turn it off, you need one of those secure token admin user accounts that we were talking about. So the cool thing about those is that you can't make one unless you know one. Like, so in previous operating system versions with FileVault under HFS Plus, the FileVault users, literally root could make a new FileVault user. And the equivalent has been drawn between FileVault HFS users and secure token users, but really it's a night and day difference. On APFS, a secure token user is a crypto user, a cryptographically enabled user on your account, and it has access to these new APIs for doing, I can access this file when this machine's locked or unlocked, and like at the APFS level. The way Apple has designed it, once one secure token admin exists, all additional secure token admins must be created with the password of the first one. And the way that most of the time that secure token admin gets created is the first person to log into the setup assistant, to the Mac, basically. So chances are, if you haven't checked out your fleet, a bunch of your users are the secure token admins on their devices, but you don't have any utility accounts that you actually know the password of any of those secure token users that you could actually grab one of these Macs and then change that configuration setting. Because secure token management is not really a thing that's available in Mac OS right now. It's literally got to know the actual password. If you attempt to use root to run the password command to change the password of one of these things, the secure token password is actually stored at the APFS level, not the Open Directory level. So root, not having access to, not being a secure token user, if you change the password, you've only changed the Open Directory half of the equation. The secure token password is still the previous password that you didn't know. So you can't actually brute your own way into having a secure token user on any of these devices. So from a forensic standpoint, these devices are horrible to get into. So I would really recommend reading, for instance, additional stuff on here, like Duo had a big write-up about this secure storage. As it turns out, that part where the storage is routed into the T2, it allowed Apple to do a new trick, which is that instantaneous encryption, because the volume at the block level starts out encrypted with an effaceable key. So now we're talking about, okay, cool, I have, let's say I don't have a secure token account on this device. I can't get in and boot stuff. I could still go into target disk mode, right? I can go into target disk mode and I can just bring the raw volume of this device up on here, and I can just DD the bytes out, and we can, you know, try to brute force the password or something like that. It's a nice idea. On previous generations of Mac, that actually worked. So on the new generation of Mac, the way that it works is some of the cryptographic primitives for that block level encryption are actually stored and non-extractable in the secure enclave itself. That means that the volume unlock key for the device, for the contents of the device, is entangled with these secrets that are stored in the secure enclave and not actually extractable in any way, shape, or form, other than attempting to just pass it a password directly and access the volume. That means that where before, on non-secure boot devices, if you had an APFS volume, you could grab a DD copy of it and brute force offline the password of this volume. Dictionary attack. You just pass plain text passwords to it and just attempt to actually do it. On these new devices, part of the key is a secret that you don't get, and it changes the password in such a way that if you can't do a raw dictionary attack, you can't do a dictionary attack anymore. You can only do raw key attacks. So we're talking about something like, you know, end of the universe type scenarios in terms of attempting to brute force these volumes. So cool. So we can't get in with secure token because our users have it and we don't know the user's password, and we can't get in because we can't offline brute force the volumes because the key is partially stored in a non-extractable hardware enclave on there. Even better, you're like, cool, all right, so we'll use a secure enclave. We'll just attempt to just, you know, run diskutil, attach unlock on there and just attempt to brute force that. Funny new note in that T2 white paper. So not only does this secure enclave enforce hardware delays, much like you'll see on iOS device, but it actually has maximum attempts. 30 attempts per unlock token type that is on the secure boot volumes. 30 attempts per type with a maximum total of 90. The most important part is this last part. Once these attempts are exhausted, the secure enclave will no longer process any requests to decrypt the volume or verify the password. So that's all you get, folks. 90 attempts to do a dictionary attack against the volume. I hope your dictionary is awesome, because 90 is not a whole lot. I mean, you got to realize, you know, Apple is going down the route of attempting to bring the security model that they have on iOS devices to Mac devices. They are cribbing from it, stealing from it, whatever you want to call it. I don't care. It's good. Mac has needed this for a long time. But the side effect of this is that this stuff has gotten out of the gate, and I don't think a lot of people realize that it's out there right now. And from a fleet standpoint, ours are less than 10% of our fleet right now, secure boot devices. But still, they're out there. Like, there's a lot of them. And if you've got these practices that you've done from a security standpoint in your environment where you're like, hey, we're going to have a simulation, you know, for employee potential data loss scenario, we need to grab their device, we need to find out what's on their device and stuff like that. If you haven't tested this against a secure boot device, you may need to reevaluate the processes that you have, because you may not realize how alien these things are under the hood compared to all the other Macs that you've seen within the last few years. Like I said, it's not the end of the world. You just need to talk to your admins, find out, hey, do you guys know anything about this secure token stuff? And they'll say, let's buy a couple beers and I'll tell you a couple sad stories and we'll talk about it. Or even more worrying, you might run into someone who's like, what? I've never heard of that. But like, talk to the people who are managing your fleet. Find out, get one for you to play with yourself. Double check your escrow of your recovery keys. So the stuff that I showed on there from a reconfiguration standpoint of the secure boot device, if you wanted to go in a secure boot utility, right now the personal recovery key and the IRK I don't believe can actually be used to unlock and change those security boot configurations, but you can at least use them for doing target disk mode attached to the device and gain access to the data that's at least inside of the device. So you do have that. So double check to make sure that this is healthy in your environment, that you're actually backing all this stuff up. And then also, I would recommend looking at, are you doing firmware password management on your devices? So like Secure Boot is an awesome step forward from a security standpoint on the Mac side of things. I was just thinking about like the Windows UEFI Secure Boot model when that stuff came out. It's still to this day, you'll see OEM vendors that are like, oh yeah, Secure Boot works great with Windows 8 and later, works great with Windows 10, whatever on here. Oh, you actually want to update the firmware on your device? Go ahead and turn Secure Boot off and then run the CD that we sent you. Like literally from their security story that they have on the Windows side of things was very not well thought out from a how do we maintain, update, manage this, all this kind of stuff. So it was very visible when it came out. A lot of tools out there told you, oh yeah, just turn this stuff off. Like I remember when it first came out on the Windows side of things, literally everybody was saying, just turn this off and you'll be happy again. But the Mac side of it, they did such a good job at hiding it in plain sight, honestly, that I don't think a lot of us, other than maybe the admin community, have honestly noticed how different these devices are. But what I was saying about firmware password stuff on here, for all the security that Secure Boot provides, if you have access to the IRK or the PRK, you could do target disk mode onto the device and pull a copy of the data off of the device. If you have the password of a user because you phished it from them or something like that, you can go in and you can reconfigure the secure boot levels on the device. So I would recommend potentially looking at doing firmware password management for your fleet and configuring one, because with a firmware password in place, attempting to get into recovery will actually stop for that password before it gets to this side of thing, and that password doesn't need to be a password that your average end user would actually need to know. So there's still additional layers of security. I feel that Apple, the choice of secure token as the benchmark for reconfiguring the secure boot level, I think was, that's what they had as the best option available at the time. I wouldn't be surprised to see it move more into the firmware password side of things. So if Apple does start making that migration where it's not based in a file system level record, because you can still go in and wipe the Mac in its entirety, and now the secure token user is gone, I'll make a new secure token user, and now I can create a new secure boot configuration for this device. So you could still get into it, you just have to do basically data loss in order for it to actually happen. So I just get this feeling that potentially you may want to look at whether you have firmware password management in your environment, because that may be like the next stage for control of configuration on this stuff. And then the other aspect on there, a lot of people say it's like yelling into a black hole, but do test and file radars in regards to the management of secure token users, potentially even the management of Secure Boot itself. We were talking earlier a little bit here about MDM with DEP and user-approved MDM. Apple has made a lot of strides from an enterprise management standpoint in providing payloads that can do some pretty deep-level security configurations via MDM and via MDM. And nothing exists right now for doing reconfigurations related to secure boot at all via MDM. Maybe that would be cool. I don't know. You could do firmware password management with it, but you can't do secure boot settings or anything like that. So I'd recommend checking out the automation that you have with, talk to your security team, talk to your admins. You need to understand these machines better because they're already out here now, and within a year or two, every Mac is going to be like this, and there's not going to be a chance for you to avoid it anymore. But yeah, don't panic. We got this. We can figure this out. You just need to be informed, and hopefully this has been a little eye-opening for some of you, and thank you. Any questions? Oh, yeah. So all you lose access to is the ability to unlock that particular volume. So you've got data loss. That's happened. But it's not a brick. You can still wipe the device or create a secondary volume or something like that. It's just that literally the ability to access the volume unlock key for that particular volume is gone. So, yeah, hard limit. Mm. Mm-hmm. Yeah, so that's a thing that can happen right now. In fact, that I believe in one of the 10.14 betas, Oh, sorry. For the people who didn't hear, he ran into a scenario where he had no secure token users on his device. He expected that the MDM created user at the setup assistant going through the login would actually get a secure token, and it didn't happen. Yeah, that can happen. So the part where I was talking about testing and filing radars, that's definitely related to that. So Apple has gotten that. So they've married secure token to the security status for the configuration of these devices. If you needed to get back into the secure boot utility, you need to have secure token user. If you needed to enable file vault on the device, you'll find if you're in that particular scenario, you have the potential to go click the turn file vault button on, and it will give you error messages even though you're an admin because there are no secure token users on the device. There's a lot of bugs surrounding that. When the initial versions of 10.13 came out with secure token users, there were a lot of crazy scenarios you could get into where you would end up having none or accidentally deleted the last secure token user that you had on your device, which is super not good. Apple has since put a lot of checks into a lot of their tools and APIs such that if you attempt to delete the last secure token user, it'll actually yell at you and say you can't do that anymore. But the act of the first secure token user failing to be created in the first place, especially in regards to MDM, there's still a lot of bugs surrounding that. So in that particular situation, we've noticed that one of the workarounds for 10.14 right now is that you can actually, if you're using an institutional recovery key and using the FDE setup command on the device, the act of passing in the institutional recovery key will go and actually bootstrap the first admin into a secure token, like it'll create the first secure token user. But from an automated standpoint, I don't really have a good solution there for you. I think some other people noticed if you go into File Vault and go click Enable on the device, in some scenarios, it'll also bootstrap the first user on there. No. Okay, so secure token users, you can only create the second and later secure token users when you have the first one. The first one is a special instance, though. There is scenarios where when you start with no secure token users, which is the default for a vanilla Mac OS, that the first one has to get bootstrapped somehow. And it basically bootstraps itself. And unfortunately, there's not a good documentation about all the avenues by which you can do that, but they do exist within the OS. And the one where it's coming in through MDM with user creation, that one's been really wonky as of late. And so I would definitely file radars on what OS versions you notice that that's happening to you in, and you should get responses back saying that we understand this and we're working on it and that kind of stuff. Anyone else? No? Good? Oh, yeah. So there, so like which APIs are you talking about? Managing the authorized users. From an API standpoint, yeah, so it used to be that there was one API that existed in 10.12, which was the one which allowed root to manage your file vault users and basically add, remove, create, all that kind of stuff. That API is gone. So all current APIs for secure token management are APIs that require the plaintext copy of a password of an existing secure token user. So yeah, there are other APIs, but the classic ones are kind of gone. So yeah, it's different.
So thinking back to the 90s, when we moved from old world ROM to new world ROM, is this going back to old world ROM?
I mean, it's another change, right? Like the firmware that was handed over ESPI to the device is still Apple's EFI implementation. It is still that. As far as the Intel side of the board goes, it looks and feels like the prior generation of Macs. It's still Apple EFI. It's just the way that it was handed and where it gets it from. That's like it's transparent to the Intel processor almost. It doesn't understand. So from a content standpoint, it doesn't seem honestly that much different firmware at the firmware level. But the mechanism behind the scenes, the Puppet Master and all that kind of stuff, yeah, that's completely different. But it also means that some of the firmware password bypasses that exist right now. So it used to be you could pop a memory chip. RAM chip off the devices and clear the firmware password on the devices, and then like 2010 or 2011 and later, they made it where it was actually the password was stored in firmware itself. Well, those SPI flash attacks, you could clear that password, right? You just put stock vanilla firmware back onto the device and the password is gone. Well, again, that doesn't work now on the T2 devices. So you really do have to do that Apple GSX ticket or whatever, where you give them the funky code that you get from pushing the funky keys and stuff like that to unlock the device now. So, yeah, there are definite differences. Hey, Matt. What's Apple doing next? Apple next. I honestly, well, first thing, all devices will be secure boot. I think secure boot is still in fluctuation, is changing. It's a fluid standard, and they're working on improving it. Like when we first saw these secure boot devices came out, you could get into the terminal on these devices in recovery mode and like run bless and like re-bless a different volume. And now that you're pointing to a different volume, the secure token users are different because it's the ones on these other volumes. Then they put that behind the password protection. So that's gone. So like they know, like they know they're not perfect on it and they're making it better and it's going to change. But I just expect it to be like this ratcheting process where it's just going to get, like, it's cool that we have these dialogues for this configuration stuff right now, but I'm thinking it's probably going to be a very short window that we have this kind of stuff. So, like, get used to the concept of data protection being the level of an iOS device in terms of data protection as the new standard on Mac. And if you aim at that puck, you're probably going to be fine. But yeah, expect secure boot in everything. And data centers too, like Mac Minis, Mac Pros, no netboot. Thanks.
Awesome. Let's do one more round of applause for Mikey Mike. Again, super interesting talk, and I think the research he's doing is really important, and especially providing feedback to Apple. As you mentioned, the specs kind of changing, so the feedback from industry and people who are actually using this in the enterprise is really, really important.